We're back, here to look at literal equations and formulas, which will be number 1.4 here. Our Common Core State Standard says rearrange formulas to highlight a quantity of interest. Okay, so basically just moving some things around and highlighting quantities of interest, like it says. Alright, so problem 1, we're rewriting this literal equation. So we have 10x plus 5y equals 80. X is the number of pizzas, and y is the number of sandwiches. It says how many sandwiches can you buy if you buy 3 pizzas or 6 pizzas? So I'm guessing 10. If I were to put this into maybe a scenario here, I would say that because x is our number of pizzas, pizzas probably cost $10, and sandwiches cost $5, and we have a total of $80 to spend. Okay, so first we're looking for how many sandwiches. Sandwiches is the y variable. Okay, so we want to solve for y. So if we solve this equation for y, we'll start with my squiggly line, separating my left and my right side. If I want to get y by itself, I need to get everything else to the other side. Okay, so first, the furthest thing away from y is this 10x over here. So if I want to cancel that, minus 10x, minus 10x. That's gone. Then I get 5y here. Now 80 minus 10x, can we subtract those? No, you cannot subtract those. Please don't subtract those. That is not 70x. 80 minus 10x, those are not like terms. So that's just going to be 80 minus 10x. That's all you can do. That's it. Okay, and then we saw 5y on this side, so we need to, this is 5 times y. Opposite of times is divide. So we're going to divide by 5. And divide all of this by 5, so you can either do the whole thing by 5 like this. But what I'm going to do is just divide each piece by 5. So divide this by 5, divide this by 5. Okay. Bang, bang, that's gone. So now I'm left with y equals 80 divided by 5 is something 16. 10 divided by 5 is 2, so 16 minus 2x. Now we've solved that for y. So now we can plug in any number for pizzas, which is x, to figure out how many sandwiches you can buy. So the first one says, how many can you buy if you have 3 pizzas? So basically we just plug in 3 for x here. So if we plug in 3, we get y equals 16 minus 2 times 3. 2 times 3 is 6, so 16 minus 6 equals 10. So if you buy 3 pizzas, you can get 10 sandwiches. 10 sand. If we buy 6 pizzas, and then I plug 6 in for x here, so that goes away, we're going to plug 6. Okay, so then I get y equals 16 minus 2 times 6. 2 times 6 is 12, so 16 minus 12 gives us 4. So if you buy 6 pizzas, you can still get 4 sandwiches. Okay. So, literal equations, basically just things that are representing something else. Okay. So like this represents pizzas and sandwiches. Okay, now this says solve the equation. 4 equals 2m minus 5n for m, so you're solving for m. Okay, so that means you're getting m. M is the one you're getting by itself. Okay, so get m by itself, then plug in these values for n. Okay, so your result should be m equals something, something, something. Okay, now when you plug those numbers in, you should get m as a number and n as a number. So go ahead, try that. You can pause this in 3, 2, 1, pause. All right, welcome back. Yeah, if you were going to solve this, you should have got m equals, it would end up being 4 plus 5n over 2. If you divided that out, it could also look like this. M equals 4 over 2 is 2, plus 5 over 2, or 2.5, n. Okay, and then you just plug those numbers in for n. Moving along. Ooh, a factoring review. Just what we need. Okay, we did factoring in chapter 0, but in case you forgot, we will go over it again. So this is factor the following expressions. So we have 4x plus 26 first. Okay, so remember when you're factoring, you're going to pull out the GCF, and the rest you're going to leave in parentheses. So the GCF of 4x and 26, well, they're both even numbers, so they go into 2. And 4 doesn't go into 26, so 2 is actually your GCF. We're going to put that on the outside. And then we divide this by 2. So 4x divided by 2 is 2x. Divide this one by 2, gives us 13. And it's still a plus on the inside. So remember, factoring is like undistributing. So if you were to distribute this through, 2 times 2x gives us our 4x. 2 times 13 gives us 26. So you can always check your factoring by distributing the GCF back through. Okay. Next one, we have negative 3x minus 9. Okay, now notice we have two negatives here. So we can actually pull a negative out. Okay, and then we look at our GCF. We have 3 and 9. What number goes into both of those? 3 does. So I can pull a negative 3 out. If I take negative 3 out of 3x, that'll just be x. If I take negative 3 out of minus 9, that becomes a positive 3. Okay, whenever you take a negative out, all of these signs change. So this will become a positive, this will become a positive. Positive x, positive 3. Okay, now this one, we have 2xy plus 6y. So if you look at your number first, 2 and 6. 2 goes into both of those, so I'm going to pull a 2 out. Do they have any variables in common? Well, they both have a y, 1y. So I can pull 1y out. So 2y is my GCF. What's left in this term? Well, I took the 2 and the y out, so I just have x left. Still have a plus, because I didn't pull out a negative, so it stays the same. And if I take a 2 out of 6, 6 divided by 2 is 3. And I took that y out, so it's just x plus 3 on the inside. And again, you can double check that by distributing it back through. Alright, 9x minus 18. 9 goes into both of these, so I'm going to pull 9 out. That leaves us with x here, minus 2, because 2 times 9 is 18. Now last one, we have ax minus bx. Okay, in this case, we don't have any numbers, but, so we just look at the common variables. So they have what in common? Well, they have one x in common, so I can pull that x out. And then I have a left here, minus b left in the second term. Okay, so that's how we factor these. Now factoring, you're going to use factoring to solve this next equation, which is why we're reviewing it now. So if we look, here we go. It says, what equation do you get when you solve ax minus bx equals c for x? Okay, now the problem here is we can't solve this for x right now because we have two x's, and they're not like terms because they don't have the same variables. Okay, they both have an x, but this one has an a, this one has a b. So we can't combine those right now. So what we have to do is we have to factor. Okay, so if we look at this left side here, we have ax minus bx. You know that they have x in common. Okay, so when you factor this, just like we did in the previous slide, we can take an x out, and then it becomes a minus b. Okay, and it still all equals c. Okay, and then, so now we have this down to 1x. Instead of having two x's here and here, we only have 1x. So this becomes solvable now. So now to solve this, squiggly line, this is x times all of this. So really we want to leave x, so I'm going to divide by everything in the parentheses. So to get rid of that times, I'm dividing fraction line. I'm going to divide by my parentheses a minus b. Don't really need those parentheses, but I'll put them there just for fun. A minus b. Do the same thing to both sides. So now a minus b divided by a minus b, those are gone. Okay, and then we're just left with x on the left side equals c over a minus b. Okay, and then it says, what if we knew that a equals 8 and b equals 5? Well, we could plug those in originally, and then it becomes a much easier problem to solve because we get 8x minus 5x equals c. And then we can combine these like terms because they're both numbers now instead of a and b. 8x minus 5x is 3x equals c. And then x equals c over 3, because we're going to divide this by 3. Okay, so we'd get that. We could also plug that in right here. We could plug in our a and our b. So we'd get x equals c over a would be 8, b would be 5, 8 minus 5 is 3, so c over 3. Same thing. Okay, but when you have x's like this and you can't combine them, you have to factor it out. Okay, so factor the x out first, and then you can solve. It's kind of a tricky little problem there. Alright, a couple more things to do. Okay, what equation do you get when you solve this equation for x? Okay, in this one you only have one x here, so no factoring required. So I'm going to let you go ahead and try that. You just need to isolate your x. Okay, so go ahead and pause this in 3, 2, 1, pause. Okay, now when you solve this for x, you should have gotten x equals negative t minus r all over p. Okay, that's when you're isolating x. If you did not get that, look back, try it again, or you can ask me tomorrow. But let's move on. Okay, so we have all these formulas here. A formula is an equation that states a relationship among quantities. Okay, so all these formulas you should know. Okay, or if you don't know them, I would write them down somewhere. Okay, the perimeter of a rectangle is 2 times the length plus 2 times the width. Circumference of a circle is 2 times pi times r. Anything with a curve or a circle, you'll have to use pi in it. Okay. Area of a rectangle is length times width. Area of a triangle, 1/2 base times height. Area of a circle is pi r squared. If you're looking for distance, distance equals rate times time. And then temperature, this is one that probably most of you don't have memorized, but this is Celsius. So if you want your temperature in Celsius, it equals 5/9 your Fahrenheit temperature minus 32. So Fahrenheit temperature minus 32 times 5/9 will give you the Celsius temperature. If you need to write those down, I would pause the video because I'm moving on. Alright. This says, what is the radius of a circle with the circumference of 64? Round to the nearest tenth and use 3.14 for pi. So, we know the circumference of a circle is c equals 2 pi r. If you want to find the radius, we could solve this for r first. So, I'm going to put my squiggly line down. Here's r. This is all being multiplied. Okay. So if I want to solve for r, I just need to divide by everything that's being multiplied to r. So divide by 2 pi. Divide this by 2 pi. Bang, bang, chow. So then I'm left with r equals c, your circumference, divided by 2 pi. Okay, you can do it that way, and then plug in your circumference, which would be, what does it say, 64. So 64 divided by 2 pi. And then figure out what that comes out to be, which would be approximately, it says use 3.14 for pi, so if you're dividing this on your calculator, make sure you put this in parentheses, so you divide it by 2 pi, not just by 2, and then divide it by 3.14, so about 10.2, if we're rounding to the nearest tenth, 10.2, what are we in, feet? Feet. Okay, you could do it that way. You could also plug the circumference in first. So let me erase this stuff. So circumference equals 2 pi r. You could have plugged that in. So circumference is 64 equals 2 pi r. And then solve that. So divide that by 2 pi. Either way, same thing. Okay, you should still get about 10.2 feet for your radius. What is the height of a triangle that has an area of 24 square inches? Remember, area is always in square units. And a base with a length of 8 inches. Okay, so area of a triangle is 1/2 base times height. Okay, so go ahead and solve that for, I don't need you, Siri, right now. Goodbye. Okay. Anyway, go ahead and plug your numbers in and then solve for, we're looking for the height, so you're solving for h here. Alright. Okay, last one we will do. This says the monarch butterfly, which you can see half of its wing right here. The monarch butterfly is the only butterfly that migrates annually north and south. The distance that a particular group of monarch butterflies travels is shown. It takes a typical butterfly about 120 days to travel one way. What is the average rate at which a butterfly travels in miles per day? Okay, so I clearly didn't read this question before I cut it out because I didn't put the distance here, which was supposed to be shown in the picture. So let's skip this one. Yes. I would much rather read about gray whales migration instead of butterflies. So let's do this one instead. Okay, Pacific gray whales migrate annually from the waters near Alaska to the waters near Baja California, Mexico, and back. The whales travel a distance of about 5,000 miles each way at an average rate of 91 miles per day. How many days does it take the whales to migrate one way? Okay, so this is a distance problem. So we know our distance equals rate, which is technically speed, times time. Okay, so it says how many days. So we're looking for t here, time, how many days. So if I want to solve this for t, I need to get rid of r. So that's times r, so I'm going to divide by r. Divide by r. Bam, that's gone. And then I get time equals distance over rate. Okay, and then I just plug in what we know. So we know the distance is about 5,000 miles each way, and it is asking for one way, so no tricky things here. So I'm going to plug in t equals 5,000 miles divided by my rate, which is 91 miles per day. And then it says about how many days. So if we divide those, 5,000 divided by 91, we get about 54.95, or approximately 55 days. 55 days for the whales to travel from Alaska to Baja California. Alright, that is all for today, folks. I will catch y'all on the flip side. Hope you guys enjoyed the video. Let me know if you have any suggestions for future videos. Unless they're bad suggestions, then keep those to yourself. Alright, see you guys later.